Hey everyone, we're going to get started with the review here. So we're going to be going over some logs for the retest that's happening on Tuesday. So I'm just getting all my fabulousness ready here, pen and tablet and so forth. Let's see what we have. Let's see if my pen's going to work. All right, so which of the following best describes the transformations for f of x? So taking that first function and then how do we turn it into this second one over here? So to do that, the things that I see right here, we have this -3, and hopefully you remember, I know it's been a long time, that -3 is a k value or a vertical shift. So this is telling me that we go down 3. And then the other number we have here is the +2. That's in with the x. That would be an h value. And remember, h does the opposite of what it looks like. So it says +2, but really that's going to be going left 2. And it's left because, again, it's an h value. So left 2. And then we would just look for left 2. There we go. Sorry, trying to make this look halfway decent. All right, so then we would look for those two things, shift left 2 and down 3. Looks like answer choice, this one. Awesome, onwards. Next one. This one, you'll notice I have the answers at the bottom because I'm not going to use a calculator in the screen. And when I post the actual PowerPoint, I'll include a screen from Desmos because you have to be careful. You might need to practice using Desmos to get the proper answers. So anyways, I'll have that up, but that's just for your reference. So I'm going to go through and let's start reading, and we'll underline and highlight some information as we go. Timmy has $7,000 to put into a savings account. So right there, we are starting with P. Our principal is $7,000. And then he's trying to find the best bank to make the most profit for his money after 9 years. So that 9 years is going to be our time. Then he has a choice of 2 different banks. He has Bank of Tockwitz or Titan Credit Union. So starting with the Bank of Tockwitz, he could earn a rate of 5%. So the rate of 5%, I would write that as R equals 0.05. Remember, you have to change the percent to a decimal. And then with a monthly compound, that would be N equals 12. So the number of times we're going to compound the interest in a year is 12 times because there's 12 months. All right, then I would go over to my next part here. The Titan Credit Union, so this is our second option, offers a rate of 3% interest. So that rate would be 0.03, again, writing it as a percent. And then it says that it compounds continuously. And so this one, that continuously, is our hint that we're going to be using E in our equation. All right, so these two problems actually use 2 different equations. If I go back to the first one, because we have compounded monthly, this one is going to use A equals, sorry, it fell out of my head for a second here. Let's see, P times 1 plus R over N times, or I'm sorry, to the N T. All right, so then when I go and fill in those numbers, I get 7,000. 1 plus my rate for this one is 0.05 over 12. And then to the 12 and then times 9. So the issue that you're going to have if you're using Desmos as a calculator is the exponent. Once you type in the 12 as an exponent, then it's going to pop the 9 back down into a regular problem. So on Desmos, we just put parentheses around the 12 and the 9 and said we were multiplying. But you'll see that when I post that for you later. All right, and so that, once we solved that, you should get this answer down here. Sorry. Yep, this answer right down here. Okay, then on to the other one using PERT. Okay, so that was the hint there. Sorry, the equation that we want is the other one, which is P times E to the RT, or PERT, the shampoo equation there. Shampoo continuously. All right, so then we're going to plug in our numbers. So we get 7,000. E remains E. And then our rate, 0.03, and then times 9. All right, so then once you calculate that, you should get this answer using a calculator, using Desmos. And then our final thing would be to decide which bank we should choose. So how would we know which bank to choose? We want the directions say we want to make the most profit. So which one do we get more money? From the first one, which is Bank of Tockwitz. So we would invest our money in Bank of Tockwitz because that's going to end up giving us the most money. All right, let's go on to the next one. Okay, here we go. So write as an exponential equation. This is one of the most basic log problems that we have. When we want to go back and forth between logs and exponents, we use the swirly. So we always begin with the base, and then we swirly to the right and swirly to the left. And so that would give us 2 as the base, because it was the base, so it always stays the base. Then the 4 is the exponent, equals the 16. Remember, the question that log asks is what exponent. So this problem says 2 to what power is 16? Oh, the answer is 4. And then you can see that in our exponential version. But there's your exponential equation. We are done. Next one, use properties of logs to simplify. We have an E, and then we have a natural log. So hopefully you remember a natural log always has a certain base, that is base E. And we don't usually write it, but I'm writing it there because if the bases match here with the log and then this base right here, if these two match, they cancel, and the answer is 12. All right, forward. This one, find the exact value. So there's 2 different ways I'm going to show you how to do this one. The first one is sorry, I lost my train of thought. To use some of our properties of logs using expanding, condensing stuff. The other way is to do what question a log asks. So I mentioned that when we see the word log, that's the same as asking what exponent or to what power. Sorry, that word got too big for me. So we want to keep that in mind when we're doing logs because that's very handy. So let's see what exponents. Okay, so I'm going to start with the log question version, and then I'm going to show you the other way. So the log question version would be looking at these 2 logs since there's no variables in them, and just looking at the numbers. So this first one basically asks 3 to what exponent equals 3. So I'm saying 3 to what power equals 3. Well, the answer to that is 1. Then if I do that same thing over here, again, 3 to what power is 81, or I can write it out, 3 to what power is 81. The answer to that is 4. 3 to the 4th is 81. So if I take these 2 log expressions, I can simplify the whole expression to 1 minus 4. I just brought the minus sign down. So the whole log base 3 of 3 turns into 1. Log base 3 of 81 turns into 4. And then I just do a very simple problem. 1 minus 4 is negative 3. So that's the answer. The other way you could do it is you could say, hey, I'm subtracting. I'll do this one in a different color just to make it a little bit easier. Okay, so you could look at this and say, guess what? I'm subtracting. So that means I can combine my subtraction into a division problem. So it would be 3 over 81 because it's always the first one over the second one. And then if I reduce that even, that would give me 1 over 27. 3 over 81 reduces. Basically, I divided top and bottom by 3. All right, then I'm back to basically asking that question, what exponent? So I could set this equal to x and swirly, or just ask the question, what exponent? Same thing. So I'm basically saying 3 to what power is 1 over 27. So quick reminders here, if I want to turn a whole number into a fraction using an exponent, that means a negative. Other than that, how do I get from 3 to the 27? 3 cubed would be 27. And then because I want it to be a fraction, I make the exponent negative, and that works out, and you can check that. So the answer here is, again, -3. All right, let's go forward. Condense. This one is kind of involved. I might do it two ways. We'll see how I feel as we go through it. All right, so when we condense, this would be doing the process. I consider it going backwards. So going forwards, we would put all of our multiplication and addition, we'd spread it out, and then we would plug anything that we can. But going backwards, we're actually going to unplug. So if I look here, any number in front of the log can be unplugged. So I'm going to unplug it like so. So I would have log A minus log B to the 1/2 minus log C to the 3rd. And then from there, I would take my subtraction here and turn that into division. So I would say log A over. So then I'm dividing two things here. I'm dividing B to the 1/2 and C to the 3rd. So that would be my final answer, but I do feel like it's a little bit maybe confusing. So another way that we could think about this is we could, in this step right here, I could have, to make it a little more obvious, I could have factored, said log A minus, let's see, log B to the 1/2 plus log C cubed. And if you look at that, if you distribute that negative back through, you'll have the same expression that we have over here to the left. So this might help you to see why both things are divided in that way, because it's subtracting both things, and the two things have addition, which means those two things have to be multiplied. We see that in our answer. Just maybe another way to think about it to help you out. All right, let's go forward. To expand this one, two different ways you could do it. You could, you could distribute your exponent and say this is natural log r to the 5th, s to the 5th. And then we could split that into multiplication turns into addition. And then we would do the best part, plug, like so. And we get 5 natural log r plus 5 natural log s. So that's one way to do it, and that is the answer there, right there. Another way is at the beginning when we had natural log rs to the 5th, you could have actually plug to begin with. So you would have 5 natural log rs and then split it. When you split it though, since the rs was together with the 5 natural log, the 5 natural log goes with both. So you have 5 natural log r plus 5 natural log s. So either way, you get the same answer. All right, number 8, which of the following are equivalent to this expression? So there's lots of ways we could answer this. Looking at our answer choices, seeing all those fractions tells me this is change of base, which basically means that I can turn this log base 4 into any base I want. Typically, we make it into a common log. And to do that, we build this fraction where it says log over log. And then the numbers from our original expression, we steal those. The base always goes in the bottom, and the other number is going to be in the top. So that would be one possible answer, which I see right here. That's answer B, this one. But common log is not the only way you could do it. You could also do it with any base you want, including a natural log. You could do pretty much anything. So if we look at answer choice A, it has the same thing, only natural logs. So that would also be correct. The only problem with C, so C could also work with the base 3. The problem is that the 4 and the 256 are in the wrong locations. So that one is not correct. Then if I look at the last two answers, my last two answer choices are numbers, which don't seem to have anything to do with change of base. They're just numbers. So with that, if I have just numbers, I might go back to the original question and ask the log question. This log means what exponent. So this is asking 4 to what power is 256. And so if you play around with that and try some numbers there, if you don't know it, that's okay. Just type it into a calculator. 4, it's probably not 4 squared. Oh, I'm sorry, not play with numbers. We have numbers to choose from. We want to look at 2 or 4. So if the exponent was 2, this would say 4 squared, which we know is not 256. So that's not going to work. So then really the only one we have to try is the 4. So if I try 4 to the 4th, it actually does work. So that is my third answer. So there are 3. All right, last one, this one looking at the graph. So I'm going to go to my original graph and talk about basics for graphing exponentials. If I was building a t-chart here and I plugged in a number for x, specifically if I plug in 0, then e to the 0 or any number to the 0 power is 1. So that 0.01 is kind of an anchor point for exponentials. So I'm going to kind of look at where that moves in the graph for each one. So I'm going to go through the shifts and start with A, where it says shift left 2. So if I shift that point left 2, that would put that point right there. Then I'm going to look at the graphs and see which graph has a point that's right there. And if I look at it, it looks like actually number 1 has that same graph. So this would be number 1, or that same point. And then I'm going to change colors. Let's go to B. It says shift up 2. So if I take that point and shift it up 2, of course, the whole graph would shift up 2. Then look back at my graphs. The one that seems to match that is over here, number 3. It has that shift up. Oopsie, shift up 2. There we go. A little crazy with my numbers there. Okay, then change colors. And let's go to C, which is shift down 2. So if I look at that, down 2 would put me down here. And I'm looking for a graph that has a point down there. It looks like number 4. So this would be number 4. And then finally, there's only one left, but let's still check it out. Shift right 2. So this would be right 2 would be right here. And the one that matches that is right over here. That's number 2. And that's it. Congratulations, you made it through the review.